important questions from D and F block elements. Today's important question starts from the manganese Mn2 plus compounds are more stable than Fe2 plus towards oxidation state to their state plus 3 state. Why? Okay, for this question, let us go and analyze the electronic configuration. Now, Mn2 plus. Okay, Mn atomic number 25. So, Ar 3d5 4s2. 4s2, it will be cancelled because 2 plus. Now, the electronic configuration as we are writing in this electronic configuration 1, 2, 3, 4, 5. It is completely half filled. So, half filled and completely filled are more stable already you have learned, right? So, this is no more electrons to contribute. Why? Because it is half filled and it is more stable. It cannot come back to Mn3 plus. It cannot go forward to Mn3 plus. It cannot oxidize to Mn3 plus. Whereas Fe2 plus, Fe atomic number what it is 26. So Ar 3d6 4s2. So 4s2 will be cancelled because Fe2 plus. So 3d6 now electronic configuration if you put 1, 2, 3, 4, 5 and 6. So one more electron can contribute. So that means Fe2 plus can converted into Fe3 plus. That is what Fe3 plus if it goes means here this electrons it is completely going out means it is more stable. So comparatively Fe2 plus Fe3 plus is more stable than Fe2 plus because it can contribute one more electron to come forward to Fe3 plus. That's what they mentioned. Mn2 plus it's more stable than Fe2 plus. Fe2 plus what happened towards oxidation to their state Fe3 plus state. That is what. Now, I hope you got a clear idea because here half filled cannot further oxidize to become Mn3 plus, whereas Fe2 plus can further oxidize to become Fe3 plus. Why? Because it can contribute one more electron to oxidize to Fe3 plus. Whereas here, half filled, completely more stable. Hope you are clear with it. Okay, now the next question. Scandium 3 plus is colorless in aqueous solution, whereas titanium 3 plus is colored white. Generally, in transitional elements, those who are having unpaired electrons are eligible to get the colored complex. Right? Okay, now here Sc3 plus, that means atomic number 21, electronic configuration Ar 3d1 4s2. Yes, 3 plus no. So the complete set will be going out. That's what you are getting 3 plus. So that means here d orbitals it is 0. There is no d orbital electrons only available. So d orbitals 1, 2, 3, 4, 5. So it is d not. So dd transition it does not undergo dd transition at all. That's what it is a colorless. Whereas titanium 3 plus here 22 electrons. So if you are writing electronic configuration 3d2 4s2. So whereas here this electron will be going here -1. So naturally you are getting 1, 2, 3, 4, 5. One electron will be there. So that means D1. So DD transition, it's available because it is undergoing DD transition because it is having unpaired electron, whereas here there is no unpaired electrons. So it is a colorless, whereas here it is a colored complex. Why? Because it is having unpaired electrons. So it is having unpaired unpaired electron and it is undergoing DD transition. So it absorbs light from the visible region and exhibit towards the complementary radiation colors. Hope you got a clear idea why scandium 3 plus is colorless in aqueous solution, whereas titanium 3 plus is colored because of unpaired electrons and it is undergoing DD transition, whereas here scandium 3 plus does not having unpaired electrons in the d orbital and it does not undergo DD transition. Hope you got a clear idea about the second question, and these both questions are very important and yes, it is a long answer type question. Hope you're clear. Okay, now let us go for the second question. Here, highest oxidation state of a metal exhibits in its oxide and fluoride. Why? There are four main reasons I can give. Because oxygen and fluorine are strong oxidizing agent, highly electronegative, and it can provide the energy to form a transition metals in higher oxidation state and it's very small. So these are all the points I can provide for this question. Yes, first and foremost what it is? Here oxygen and fluorine are strong oxidizing agent. Strong oxidizing agent. Okay, now the second point, highly electronegative. Highly electronegative. Okay, now third one, it's very small size actually. Small size. Okay, atomic size, it's very small. And the fourth one, can provide what it is? Energy to form the transition metal ion in higher oxidation state. Higher oxidation state. So these are all the points we can provide for this question. Why? Because hope you understand all this. Okay, now the next one also correlated with fluorine only. Transition metal fluorides are ionic in nature, whereas bromides and chlorides are covalent in nature. Why? Actually, answer it is very simple. You know, fluorine is more electronegative than chlorine and bromine. So, naturally, fluorides are more ionic than bromides and chlorides. Hope you got a clear idea. Fluorine, it's more electronegative. More electronegative than chlorine and bromine. So, naturally, fluorides are ionic in nature, whereas chlorides and bromides are covalent in nature. Okay, hope you got a clear idea. Main reason, it's more electronegative. Which is more electronegative? Fluorine, it is more electronegative. Okay, let us go for the next question. Next, one more interesting and important question. This is higher order thinking skill HOTS. Identify A to E. As we look at this only, it looks like puzzle. Yes. Come to this point, CuCO3. If you heat, you will get CuO plus D. That means some other compound it's coming. Okay, now here let us come this side. CuO, if you heat with copper sulfide, you will get compound A, and then concentrated HNO3, you will get compound B, and NH3 in aqueous, you will get compound C, that is bluish in color solution. Yes. Now, this D reacts with calcium hydroxide, you will get E, and if it reacts with carbon dioxide, it is a milky color, and that is reacts with CuH, CO3 twice. That is actually you will get that solution. That solution, it is a colorless. Here bluish color solution, here colorless. Come on, let us find A to E. What are those points? Yes, the first and foremost, CuCO3. If you heat, what you will get? CuO plus CO2. Definitely carbon dioxide only, because CuCO3, it is there. CuO plus CO2. Okay, now this is what it is. First equation. This we got it. D we got it. So this is D. Right? Now the second one. CuO plus CuS. If it reacts heat, naturally you will get Cu plus SO2. Okay, now this is 2 means here 3. 1, 2, 3 yes, SO2. Okay, now this is A. This is an element, not compound. This is element A, you got it. Okay, now A, third one. This is Cu plus HNO3, concentrated HNO3. You will get CuNO3 twice plus NO plus H2O. Right? Okay, now balancing here. If we put here 2, here. So that means here if we put it 4. So here 2 and here 2. And H, 2H. 2H2. Yes, you got it. Okay, now fourth one. This is compound B. Right? Now, this compound B reacts with ammonia. What it is? CuNO3 twice plus NH3. You will get complex compound. What it is? CuNH3 4 times NO3. Here no NO3 twice. Here you will get complex compound, right? So that means here 4 no, here 4. Yes, this is a complex. That means this is C, compound C. So naturally this is bluish color solution. I hope you got a complete idea about this side. Now let us go for that side. What is that? That side. Hope you're clear with this. Okay, now I'll rub this. Now carbon dioxide only that side, right? Okay, now this carbon dioxide, CO2, we just keep it. That is a D combined with CaOH twice. Calcium hydroxide. So calcium hydroxide, when you pass carbon dioxide, you know very well. That is calcium carbonate. CaCO3, you know very well. So that is what it is. Compound E plus H2O. Compound E and H2O. Right? Now, again, carbon dioxide passing, you will get that milky color when you are adding what it is, carbon dioxide. Here you see CaCO3, already H2O it is there, and CO2. You will get CuHCO3 twice. So it is a colorless solution. Here it is a milky solution, milky color solution. When you are passing carbon dioxide and water, it is there in that water, again you are adding, you will get colorless solution. I hope you got a clear idea. This is E and this is what it is, colorless solution. I hope this is A, it is what it is, Cu, and B, CuNO3 twice, and this is blue color solution, CuNH3 4 times, NO3 twice. Hope you got a clear idea about that C. And of course this is CO2 and this is what it is, CaCO3 plus H2O, and this is carbon dioxide. If you have got, you will get it milky color. Again it reacts, you will get what it is, colorless solution, which is you are getting CuHCO3 twice. Hope you got a clear idea about A to E. Okay, let us go and see some other important questions. The next question, transition metals have greater tendency for the complex formation. Why? It's important only. 2020 corona time they asked very simple and easy question. Yes, you know what is the reason? Vacant d orbital, smaller size of the cation and a higher charge. These are the main three reasons for this question. Transition metals have greater tendency for the complex formation. See, first one, vacant d orbitals and the smaller size of the cation, smaller size of the cation and a higher charge. So these are all you can give for this answer. Hope you got an idea. Okay, now highest fluoride, the second question, highest fluoride is Mn4, whereas highest oxide it is Mn2O7. Actually, this also very interesting and simple question. Mn2O4 can form double bond, whereas MnF4 can form single bond only. See, Mn oxygen here, Mn here it can form double bond with oxygen. Okay, like Cr2O7. Okay, it can form double bond, right? So this is Mn2O7, structure of Mn2O7. It can form double bond. It can form double bond. Whereas Mnf4, it form only single bond. Single bond. Hope you got a clear idea about this. This is very simple. It can form Mn4, sorry, MnF4 can form a single bond, whereas Mn2O7 can form a double bond. Hope you got a better idea about these two questions, and it's very important also. Okay, let us go for some other question. Here, with reference of structural variability and chemical reactivity, write the difference between lanthanoid and actinoid. It's so simple. Lanthanoids are mostly plus 3 oxidation state, whereas actinoids are plus 3 to plus 7 oxidation state. Very few elements are plus 2 and plus 4. Come on, let us write that so that you will come to know lanthanoid and actinoid difference, like I will write it. So mostly it is plus 3 oxidation state. I just write it like this, oxidation state. Very few elements are plus 2 and plus 4 oxidation state. Okay, now here starts from plus 3 to plus 7 oxidation state. Okay, now this is the first point. Now second point, it is less reactive due to high ionization energy. So this is very less reactive due to high ionization energy, whereas here more reactive due to low ionization energy. That's all. Only these are the two main important points for the lanthanoid and actinoid series related to that reference with the structural variability and the chemical reactivity. Hope you got a better idea about these two answers. Yes. Now the second one, it's simple question only. Name the lanthanoid series which is well known to exhibit plus 4 oxidation state. Cerium only, it is a main. Cerium can exhibit what it is, plus 4 oxidation. Only this answer, it's enough. Cerium, you can write it cerium name also. Hope you're clear with that. Simple, you just think it in a logical way, you will get the answer. Hope you got a better idea. Concept, if you are thorough, you are able to write your answer clearly. Please subscribe this channel and click the bell icon so that you will get